try and add some bare metal nodes back into our NSX fabric. So right, so my current NSX fabric looks like this. I have two ESX hypervisors sitting in here. 1 and 2. They both use a physical NIC to provide the overlay back into the network. I'll call this guy 1, 2. We also have an NSX Edge VM that is connected to my upstream router using BGP. So the goal of this lab is to add in a bare metal server. I already have a couple running. I have an NSX-T manager, obviously. My bare metal server is sitting up here. It is connected to the same management network that the other hosts are on as well. So its ENS 192 interface is using 192.168.0.144. And it will have a dedicated physical interface to connect back into the core of the network also. We can share a single interface and provide the management on VLAN 0, so untagged, and then the overlay sitting on the tagged VLAN, which I believe is on VLAN 206 for all the tunnel overlays. But I'm going to deploy this with a dedicated physical NIC to provide my overlay. Currently we have all our default route is heading this way. Back through the management network, and the goal will be to remove that and forward all the traffic back down this way. So we'll be forcing all traffic to pass down through the fabric connection back down towards the internet down here, and then we can go through and have a quick look at the firewall, which is actually going to be sitting on here as well, which is configured through the NSX-T management interface. So let's see if we can get onto our server. Right, actually I was already logged into it, that's good. We use a root account to log into this, but we need to have a root privilege level account to actually install software on here as well. So the first thing we need to do is just probably run apt-get update, make sure we've got things running as we need to. And we've got access to the package manager, obviously routing's working as well. We do need to install a bunch of third-party libraries as well, and one thing just to remember, just make sure you don't have IP tables running as well, because that will block tunnel formation. I've had that catch me before. Third-party packages to install. Run through this, it's going to actually install a couple hundred meg of files here. So we need to install these packages first before we go and install the NSX-T provided packages. So let's let it run through and do that. Have a quick look at my lab environment inside NSX as well while we're sitting here. So right now I've got a tier 0 gateway, which is providing my BGP peering upstream. I've got a single tier 1 router, so one tenant on here called lab, and I have a single network segment connected to this as well called my lab demo machines, which has both virtual machines and it's also where the bare metal will connect to. So I will have virtual machines on the 192.168.22 network and also bare metal hosts connected to the same subnet as well. Alright, so it's installing those files. So each of these hosts, whether they're a Linux host or a Windows server, need to have the VMware provided NSX tools installed as well. For Linux, we support Red Hat, CentOS flavors with RPM, and obviously Debian or Ubuntu servers, as well as Oracle Linux as well. And Windows servers will be Windows 2016 server and 2019. I'll focus on Linux today. Alright, getting close to finishing installing these packages. I've already pre-downloaded the NSX packages. I've placed them in var/temp. I'll jump over there in a minute and we will run through the install for that. Okay, cool, that's finished. Let's have a look in var/temp. So I have my packages here as well, so I need to extract these. Audio, let's jump in here. So dpng, install these files. So we'll run through and install these. Once we've finished this, we then jump into the NSX manager, and we take this server under management from the NSX-T controller. Let it do its thing. This takes a minute or so as well. So we'll look back in our management platform as well. So looking at the topology, I've got my lab demo segment here as well, connected to my lab tier 1 gateway. Obviously goes up through peering. I've got some physical servers on here already, so bare metal 1 and bare metal 2, and a couple of VMs as well. So you can see these are all on the same subnet. There's something wrong with doing that. Oh, there it is. So you can see I've got a couple of VMs, physical servers, they're all on the same segment. They can all currently communicate with each other as well. Okay, that's still doing its build there. The neat thing is I can also show path topology between any devices on the network, even between physical and virtual as well. Right. Just wait a minute. So I'm adding a third bare metal server to this segment. The maximum we can support is 1,000 devices. Right, okay, that's all done. So now we do everything else really from here. Let's see if anything's changed. So no, we've got that interface, the management interface 192. 224 is here, completely unconfigured, and that's the way it should remain. And we don't have anything else on here. So let's get back into NSX, come into the system fabric and look at the nodes we have. So I've got my 2 ESX hypervisors here. The tunnels are up, 4 tunnels. It's a tunnel to each of the hypervisors plus to the existing bare metal and the edge machine. My standalone hosts are, I've already got BM1 and BM2, so I'm going to add BM3. And it is 192.168.144. So we have to choose what type of machine this is. So all the devices we support currently for bare metal integration. Okay, we'll grab the SSH fingerprint. Don't save that password, please. Okay, so now it actually goes and interrogates that box and grabs some information as well, so the interfaces it has. I'm going to integrate it into my existing transport zone, which is called VM overlay. And I'm going to use my uplink profile. This is exactly the same as what I have configured on my ESX transport nodes. Turn on some LRDP, tell it to use an address from the same host pool I'm using for my hypervisors. And then we're going to use the ENS 224 interface for our overlay. So now it actually will log in and configure all the elements we deployed before, so the NSX packages, to communicate back to this management platform and to configure all the interfaces we need to start using and leveraging the overlay. So some of the things we actually do get now from here as well, we do get the NSX CLI appears on the bare metal host, so we can start looking at commands on here as well. So get version is going to show me what's going on here. We can look at controllers. We probably don't have a controller connection. Oh, we do right now. Okay, get managers. Show us the manager connection. So both of these are connected now. So we've got a management connection. The controller connection is up. In my case, I've just got that one controller. So the same NSX CLI you would have on other transport nodes. So we'll start looking at this as well around some of the firewall configuration as well. So okay, that's actually successfully configured that now. So what we need to do now is actually configure this bare metal host to be integrated into our segment on the tier 1 router. So we'll do that later. We'll have a quick look and see what has actually changed under the hood. So you'll see this little warning sign here, which tells us that it is not actually connected to a network segment at the moment. So we now have this interface configured. It's probably still running through and actually configuring this interface, although we do see we actually have an IP address on the overlay fabric. So it should be able to ping some other hosts on here as well. I think 18, yep, 19. These are the hypervisors I have in the network. I think 21 might be the edge, yep. So we have connectivity for the fabric overlay now. Let's go and attach it to a network segment, select here. And you can change this after the fact as well, if you need to move the bare metal host onto a different segment. So we need to add a segment port, and we're going to call it VM3 uplink. And I'm going to give it a static IP address. So it's not a new IP address here. 192.168.22.103/24. And it will be using that as its default gateway. So we will go and actually start changing the routing behavior as well, probably from the command line. Close that. Okay, so let's see what happens now on the command line, on the host itself. So it's still busy making these changes in the background, but we will see that 192.168.22.103 address appear. Here it goes. Okay, so we've now actually allocated this. So this is actually the application interface, which is on the segment. Okay, jump back over here as well. It does take a while for these tunnel interfaces to appear here as well, but they will eventually come up and go, and they should have the same number of tunnel interfaces as the existing ones I have here as well. Let's have a look what our edge transport nodes think as well. Okay, it's got 5 tunnels up, so it should have a connection into bare metal 1, 2, and 3. Okay. No tunnel endpoints found. I'll still be working out what's going on. Okay, let's get back to that in a second. Okay, let's go and look at our topology. It does take us some time for those tunnels to be updated. Okay, we now have a third server on here, VM3. Right, 1, 2, 3, our 2 VMs as well. They're all on the same subnet. So those machines are... So I should have pinged my default gateway. Yep. I think the 12 is one of the VMs and 16 is the other one off the top of my head. The other bare metal machines are 101 and 102. So I now have full overlay connectivity. And obviously that's directly connected. So let's look at our routing table. Right, so all our traffic for the 192.168.22 network is staying on the fabric, but everything else is going over my management interface. So default gateway. Right, so now we're going to force all traffic to actually head over the fabric. Right, so I'm actually following my default route up to my peering router. Now I should be able to resolve as well. Yep, okay, so DNS is working, I can forward traffic. So now I've got a bare metal host that is entirely reliant on communicating to everything over its fabric connection, including through the firewall. Let's have a look at the firewall config actually. Get firewall, if we do get firewall VIPs, that'll give us the VIP ID for this firewall. I've only got one configured on here. Rule. I can actually see the firewall rules that are pushed down from NSX. So I've got the global sort of default stuff as well. So we can actually come into NSX-T manager and say we want to add something that's at FTP. So security, and a firewall here. Let's just say that's an infrastructure rule. Right, so we've got these rules here. Let's allow FTP as well. Okay, apply that. Now it's going to ask us to publish this change to the network, because this obviously affects every device on the network, in this case any. Alright, so now FTP has appeared here as a firewall rule as well. So we've got complete control over the networking table. We can make routing changes from NSX-T as well, or we can obviously do it from the command line. It's just another interface. And we do have complete control over security closest to the workload as well. So we're not forwarding traffic across the fabric to a centralized firewall or a virtual machine or a physical machine. It's actually been enforced directly in the kernel on this Linux host in particular. And we have complete control over a consistent firewall policy end to end. And finally, we can look at maybe some troubleshooting. Okay, let's see how virtual machine, what was it called, this guy here, gets to 192.168.22.3. Oh, here we go. Cool. Okay, so we've actually injected some packets, some traffic into the hypervisor network adapter, and we have shown you all the hops across the network and how it actually gets from this virtual machine all the way down through to the BM3 uplink interface, which is the one that's configured directly, and it was successfully delivered. Don't have a diagram then. Perhaps it doesn't work with the bare metal machine. I better look into that. So that's how we add a bare metal host. I have 3 connected now to my network. All tunnels are up now, so it does take a while for this to refresh, so don't panic if you don't see that operational. So I have a full mesh of tunnels effectively here at this stage. Likewise from my vCenter server, I have a full mesh of tunnels here as well. We only have tunnels are only signaled when there's actually a workload connected to that network on each of those transport nodes, so you may not see a full mesh. And same for my edge transport nodes as well. Right, so 5 tunnels there as well. So this should actually show me, it does this time, a connection to each hypervisor, to each bare metal workload. Right, so that's how we can successfully add these bare metal workloads, whether they're Linux servers or they are a Linux or Windows server, back into our network directly and maintain consistent security and control over both networking and the firewalls. Thanks for listening. My name is Francois Prowse, fprowse@vmware.com. If you have any questions, let me know. Thank you. Bye.